Welcome to the Bare Metal Cyber CCISO Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Artificial intelligence and machine learning are rapidly transforming cybersecurity operations. These technologies offer advanced capabilities for pattern recognition, anomaly detection, and decision support, all at a scale far beyond traditional manual methods. AI and machine learning enhance threat detection accuracy, accelerate incident response, and enable predictive security strategies. By automating data analysis and triage, these tools help address the growing volume of alerts and complexity in modern threat environments. They are particularly useful for detecting subtle or novel attack patterns that may not match known signatures. At a strategic level, AI and ML support adaptive defense, helping organizations respond dynamically to evolving threats. However, these technologies also introduce new risks and require clear oversight. The CISO must lead the organization's adoption and governance of AI and ML, ensuring that they align with business priorities, regulatory requirements, and operational needs. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. The CISO's role in managing AI and machine learning within security programs is multifaceted. It begins with evaluating where AI and ML can provide meaningful benefit, such as in detection accuracy, analyst efficiency, or threat prediction. The CISO must assess solution maturity, particularly with respect to model, transparency, explainability, and vendor accountability. If the organization cannot understand how a model works or what decisions it's making, it cannot validate outcomes or respond to audit requests. Policies must be established to govern model development, tuning, and deployment. These policies should include requirements for data quality, documentation, and ethical safeguards. The CIO/CO must also ensure that AI and ML systems are integrated with existing SOC, incident response, and governance functions so that insights are operationalized effectively. Regular reporting to executive stakeholders must communicate AI effectiveness, limitations, and any emerging risks. There are a wide variety of use cases for AI and machine learning in security operations. Behavioral analytics uses ML algorithms to model normal user behavior and detect anomalies that may indicate insider threats or account compromise. Threat intelligence platforms use machine learning to correlate and enrich data feeds, helping analysts prioritize meaningful indicators. Email security tools use AI to detect phishing, classify suspicious links, and analyze sender behavior. Endpoint protection systems apply machine learning to detect advanced malware, sometimes before traditional signatures are available. In security orchestration and automation platforms, AI is used to triage alerts, assign severity levels, and trigger playbooks based on real-time context. These use cases demonstrate the strategic value of AI and ML, provided that models are accurate, monitored, and properly integrated. Understanding the AI and ML lifecycle is essential for effective implementation. The process begins with data collection and pre-processing, cleaning and labeling datasets to ensure quality input. Model training follows, using labeled data in supervised learning or pattern discovery in unsupervised learning. After validation and testing, models are deployed into operational systems to make real-time inferences. Over time, models must be tuned to reflect changing behaviors or threats. Feedback loops from analysts and detection outcomes are essential for refining model accuracy and reducing false positives. These loops help models adapt to new attack techniques or changes in network behavior. The CISO must ensure that this life cycle is governed with consistent review, data science, and operations teams. While AI and machine learning offer promise, they also present unique risks. Poor data quality or labeling can introduce bias, leading to inaccurate results or missed threats. Adversarial attacks on models, such as evasion or poisoning, manipulate input data to produce false outcomes. Black box models that lack transparency make auditing and investigation difficult. Overreliance on automation can create blind spots if models fail silently or omit key threat indicators. Additionally, machine learning systems often process sensitive data, introducing privacy and compliance risks. The CISO must assess these risks carefully and implement compensating controls, such as human oversight, alert validation, and layered defenses. Responsible use of AI and ML requires understanding not only their capabilities, but also their limits. Governance, ethics, and compliance are central to the secure use of AI and ML. Internal review processes must be established to assess model fairness, accuracy, and accountability. Decision-making logic should be documented to support transparency and auditability. Compliance with privacy regulations such as GDPR, CCPA, and emerging AI-specific laws must be verified before deployment. Organizations must define roles and responsibilities for model development, tuning, and approval. AI systems must be included in broader security assessments and risk management processes. The CSIO ensures that governance structures are in place to manage both technical performance and ethical responsibility. Without governance, even high-performing models can expose the organization to reputational, legal, or regulatory consequences. Evaluating AI and ML vendors requires more than reviewing marketing claims. The CISO must examine the data sets used to train the models, the mechanisms for updating and tuning, and the degree of transparency offered to customers. Solution maturity should be assessed based on real-world validation, not just lab results. Metrics such as accuracy, false positive and false negative rates, and response time improvements must be reviewed. Integration capabilities with existing SIEM, EDR, and SOAR platforms are essential for operational use. Vendor policies on data retention, reuse, and privacy should also be examined. The CISO leads this evaluation to ensure that selected solutions fit within the organization's architecture and risk posture. Organizations that build their own AI and ML capabilities must follow structured development practices. Collaboration between cybersecurity teams and data scientists is critical. Use cases must be clearly defined, with success criteria tied to operational outcomes such as reduced alert fatigue or faster containment. Data quality is foundational. Models are only as good as the data they learn from. Labeling, pre-processing, and validation must follow consistent standards. Internal model development should include ethical safeguards, access controls, and documentation for review. In some cases, organizations may choose to retain model ownership and control to meet regulatory or intellectual property requirements. The CISO ensures that internal efforts follow the same governance, risk, and compliance expectations as external solutions. Measuring the effectiveness of AI and machine learning in security programs requires the right metrics. Common technical metrics include detection accuracy, precision, and recall. Operational metrics may focus on reductions in analyst workload, alert triage time, and false positives. Security outcomes such as faster containment or fewer missed threats help demonstrate value to executives. Metrics on model drift or degradation show whether models are keeping pace with evolving environments. Business-level reporting should tie AI performance to outcomes such as improved SLA adherence, lower incident response costs, or reduced dwell time. The CSO ensures that metrics are collected, validated, and used to drive ongoing improvement and justify investments. On the CCISO exam, AI and machine learning are included through terminology, scenarios, and governance questions. Candidates should understand terms such as model drift, adversarial ML, supervised learning, and unsupervised learning. Scenario questions may ask how to evaluate a vendor, govern an internal model, or assess AI risk in a security incident. The CISO's responsibility includes setting policy, evaluating performance, ensuring ethical use, and aligning AI initiatives with enterprise risk and compliance strategies. Integration with GRC, SOC, incident response, and audit frameworks is key. Strategic deployment of AI and ML enhances security capabilities, but requires strong leadership, transparency, and oversight. Thanks for joining us for this episode of the Bare Metal CISO Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.